Hello everyone. In this video, I will be talking about the probability problems which were asked in the September 9th, 2020 shift 1. So as we can see, if you have seen the paper, that there were about seven problems, five, six, seven questions which were asked from probability section, which includes statistics as well. So let us look at the problems one by one. So the first problem that was asked was calculate the mean deviation about the mean for the following data set. So this was one of the very straightforward problem that could be asked. All you have to do is just follow the process and you will get your solution. So over here what I have done is I've been given class interval 0 to 4, 4 to 8, 8 to 12, 12 to 16. I have represented this, I have changed it to this data xi. So what I have done is I have converted this interval data to a single point data. So what I have done is 0 plus 4 divided by 2, which is equal to 2. 4 plus 8 by 2 is equals to 12 by 2 is 6. 8 plus 12 by 2 is 10. 12 plus 16 by 2 is 14. So what I have done is I have replaced this interval data by the mean of the upper limit and the lower limit of the interval, and I have kind of approximated this interval with this data. So previously you could have said that between 0 and 4 there were 4 data points. Yeah, four, their frequency was 4. So I just replace it by saying that 2 was there 4 times. Instead of 4 to 8 I am saying 6 was there. Instead of 8 to 10, 10 was there. 8 to 12, 12 to 16 is replaced by 14. So now I have the data and I have its frequency. So now it's just a routine problem where you first compute the mean of this data. So XIFI is 2 into 4 is 8, 6 into 3 is 18, 10 into 2 is 20, 14 into 1 is 14. You compute the sum of all these and you divide it by the total data points over here, which is 4 plus 3 plus 2 plus 1 is 10. So n is equals to 10. So 8 plus 18 plus 20 plus 14 is 60, divided by 10 is 6, so mean is 6. Now I compute xi minus x bar is mean, and I take the mod of it. So 2 minus 6 is minus 4, mod is 4, 6 minus 6 is 0, 10 minus 6 is 4, 14 minus 6 is 8. Now I multiply it with fi. So 4 into 4 is 16, 3 into 0 is 0, 2 into 4 is 8, 1 into 8 is 8. So summation of it is 32. You divide it by n, which is 10. So 32 by 10 is 3.2. So this was one of the simplest problem that was asked in this exam. So the second problem, the means of two groups of observations A and B are x bar and y bar, and their standard deviations are respectively 2 and 3. In order that the group A to be more consistent than the group B, then x bar divided by y bar is what? So in this we are given two data sets A and B. Mean of both the data sets are given as x bar and y bar. Their standard deviations are also given as 2 and 3. Which one is more consistent data set? So more consistent data set, let us have an example. If I have a data like this 99 and 101, just two data points, 99 and 101 in your data set A, and 50 and 150 is data set B. Mean of these two is 99 plus 101 divided by 2 is 100. Mean of these two, that is 50 plus 150 by 2 is also 100. So these two data sets, the mean of both of them are the same, 100. But which one has more standard deviation? This second data set has more standard deviation, obviously. So this one has more standard deviation. B has more standard deviation than A. So A is more consistent in this problem. So if the mean is same and standard deviation is less, then that is the more consistent data set. So now when we look at this data set, which is given to us, means are given x bar and y bar, and standard deviation are given at 2 and 3. So means are not similar, so I don't know which one is more consistent. So for that I'm using coefficient of variation. Coefficient of variation formula is sigma upon mu. So sigma, we know what is sigma is standard deviation and mu is mean. So coefficient of variation of A is 2 by x bar and of B is 3 by y bar. Now, as I said, if the mean is the same and the data set which has a lesser standard deviation will be more consistent. So if data set A is more consistent than data set B, then CVA is less than CVB, right? So 2 by x bar is less than 3 by y bar. So you take x bar over here and you take 3 over there, you will get 2 by 3 is less than x bar by y bar. So that is the solution. It's easy problem which follows straight from the formula of coefficient of variation. Now question 3. So this one is a bit tricky one. When two dice are rolled, let x be the probability of getting a sum of the numbers appear on the dice is at most 7. At most 7, that means that the sum can be 1, 2, 3, 4, 5, 6, 7, but it cannot be 8. So you will have to consider all the probabilities of 1 to 7. But when you roll two dice are rolled, the minimum that can appear is 1 on both the faces. So the minimum is 2 and the maximum for this case for x is 7. So I will have to compute the probability that the sum appearing at most 7, then it will be 2, 3, 4, 5, 6 or 7. So that will be x. And the second part of problem is let y be the probability of getting a sum 7 at least once when a pair of dice are rolled n times. So if I roll a pair of dice n times, so the sum can appear at least once, so that so the event should be like 7 is appearing once, then 7 may appear twice, then 7 may appear 3 times, n minus 1 times, or n times. Just 0 times, that is sum of 7 does not appear, is not included. Everything else is included. So that is why. Now the problem says in order to have y greater than x, the minimum n is what? Okay, so let us first compute x and then let us compute y and then see what's happening over here. So we can get a sum at most 7 when rolling two dice in the following ways. That is both 1 and 1, then 1 and 2, then 1 and 3, then 1 and 4, 1 and 5, 1 and 6. So this is 6 ways. Then 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5. So 5 ways. I'm not including 2 and 6. Why? Because that will become 8. 2 plus 6 is 8. So that exceeds 7, hence not considered. Then 3 and 1, 3 and 2, 3 and 3, 3 and 4. So 4 ways, 3 and 5 is excluded, 3 and 6 are also excluded because the sum becomes more than 7. Then 4 1, 4 2, 4 3, 5 1, 5 2, 6 1. So that's 1 plus 2 plus 3 plus 4 plus 5 plus 6, at most 7. So there are 21 total possibilities when the sum is at most 7. The total number of possibilities is what? 6 times 6? Yeah, 36. So x equals to 21 divided by total number of possibilities. So x is 7 by 12. Now we have to compute y. Okay. So for that, let us first consider the case when we throw a pair of dice and we get 7. How can we get 7 when we throw two dices? So either it's 1 6 or it's 2 5 or 3 4 or it is 4 3 or it is 5 2 or it is 6 1. So total 6 out of 36 possibilities. So when I throw a pair of dice and I get a sum of 7, the probability for the same is 6 divided by 36 or 1 by 6. So probability of not getting a sum of 7 when I throw a pair of dice is what? Just 1 minus of this, which is 5 by 6. So in the problem he says let y be the probability of getting a sum 7 at least once. So if I can get the probability that 7 never appears, I can just subtract that from 1 and I will get my y, right? So that is what I have done over here. So I never get 7 and I throw the pair of dice n times. If I throw a pair of dice and I don't get 7, then the probability is 5 by 6 as I have computed over here, which is 5 by 6 when I throw it once. So if I throw it n times, the pair, I throw it n times, what will be the pair probability? 5 by 6 raised to the power n. Okay, so that is never getting sum of 7. So probability of getting 7 at least once is 1 minus 5 by 6 raised to the power n. So this is my y. Now the problem says, what is the minimum value of n so that y is greater than x? So that I have done over here. 7 by 12 is approximately 0.58 and y is 1 minus 5 by 6 raised to the power n. So let us go for n equals to 1. N equals to 1 is 1 minus 5 by 6 is 1 by 6, which is less than 7 by 12. Very obvious. N equals to 2. Y is equals to 11 by 36, which is again less than 7 by 12. Obvious. Multiply by 3 over here, so it will be 21 by 36. 11 by 36 is less than 21 by 36. And at n equals to 3, y is 91 by 216, which is approximately equals to 0.42, again less than 0.458. At n equals to 4, y is equals to 0.51, again less than 0.58. At n equals to 5, y is equals to 0.59, which is greater than 0.58. Hence, n equals to 5 is my correct option, option C. Now, let us move to problem number 4. This is based on Bayes' theorem. So, two numbers are selected at random from the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If the sum of selected numbers is even, the probability that both the numbers is odd is. So if I add two even numbers like 2 and 2, 2 and 2 is 4, right? 2 and 2 is 4. If I add two odd numbers 3 and 3, again the sum is even. So if I add two even numbers, the sum is even. If I add two odd numbers, the sum is even. If I add an even and odd, 2 plus 3, 2 plus 3 equals to 5. So addition of an even and an odd number is odd number. Addition of two even numbers is even number. Addition of two odd numbers is even number. Okay, so we know that. It's given that when you have selected two numbers from the set of 1 to 13, the sum is even. So he's asking the probability that both the numbers is odd is what? So let us just find out what are the odd numbers in this set and what are the even numbers in this set. If I select two odd numbers, then the sum is going to be even. If I select two even numbers, the sum is going to be even. Okay. So the odd set is 1, 3, 5, 7, 9, 11, 13, which is 7 numbers. And even set is 2, 4, 6, 8, 10, 12, 6 numbers. So I can select two numbers out of these 6 in how many ways? 62 ways. 62 ways. And I can select two numbers from these 7 numbers in 72 ways. Okay, the sum of the two numbers which have been selected is already given as even. So what is the probability that the both numbers were selected were odd? So we can find that out by dividing the total number of ways in which you can select the two odd numbers divided by the number of ways in which you can select odd numbers and even numbers. So 7C2 divided by 7C2 plus 6C2. So which is equals to 21 divided by 21 plus 15 is 7 by 12. So correct option is C. It's a very straightforward problem. If you don't understand, kindly let me know. I will explain further. Okay. So the next question, question 5, it's very simple, very straightforward problem again. Doesn't require too much brain. Let x be a discrete random variable representing the number x appeared on the face of a biased die when it is rolled. What is a biased die? A biased die is something in which the probability of each of the face is not equal. So if I'm throwing a fair die, the number 1 or 2 or 3 or 4 or 5 or 6, which is the number on the face of on each face of the die, if it is fair, then probability is same for all of them, that is 1 by 6. But if it's a biased die, maybe one has low probability like it's shown over here. So since it's a biased die, all of them have like dissimilar probabilities. So k is given here, k is given here. The probability distribution function is given. Then he has asked for variance of x. So to compute the variance of x, let us first just compute these values k, right? So sum of all the probabilities has to be 1. We know that. So zero point 0.1 plus 0.15 plus 0.3 plus 0.25 plus k is 1. So zero point 0.8 plus 2k is 1. So k is 0.1. So I have computed this one and this one. They are both 0.1. Now it's a standard formula. First we calculate the mean. So mean is value of x and the probability associated. So 1 into 0.1 plus 2 into 0.15 plus 3 into 0.3 plus 4 into 0.25 plus 5 into k is 0.1 plus 6 into k is 0.1. So which I have done over here. So mean is 3.4. Now I have also made a note over here that if the dice was unbiased, what would have been the mean? So 1, 2, 3, 4, 5 and 6, all of them would have similar probability of 1 by 6. So mean would have been 1 plus 2 plus 3 plus 4 plus 5 by plus 6 divided by 6, which is 21 by 6, which is 3.5. So the mean for an unbiased dice would have been 3.5. Since it's a biased die, so it's 3.4. Now what is the variance? Variance is value of x minus mean x bar whole squared times the probability. So 1 minus 3.4 square into 0.1 plus 2 minus 3.4 whole square, which is the mean, into the associated probability 0.15, then plus 3 minus 3.4 whole square into 0.3 plus 4 minus 3 whole square into 0.25 plus 5 minus 3.4 whole square into k is 0.1 plus 6 minus 3.4 whole square into k is 0.1, so it is 1.94. So option B is the correct option. It's very straightforward and easy problem. Problem 6. 2 and unbiased coins are tossed. So again it says an unbiased coin, so that means the probability of getting a head or the probability of getting a tail, they are both equal to 1 by 2 or half. 2 and unbiased coins are tossed. The probability of having the number of heads is not equal to the number of tails is what? So if you go and say, okay, I will assume 1 head and 2n minus 1 tails, then I assume 2 head and 2n minus 2 tails, then 3 head and 2n minus 3 tails, 4 head, 2n minus 4 tails, dot 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 dot, it will take up 10 minutes. So what I am going to do is the probability of having the number of heads is not equal to the number of tails. I will just compute the probability of having the number of heads equal to the number of tails, and I will subtract it from 1 and I will get my probability, right? So if I have the probability of event, then the probability of not that event would be just what? 1 minus probability of that event. So that I will just compute the probability that the number of heads equals to the number of tails. Since there are 2 n unbiased coins, so the number of heads equal to number of tails will be both n, right? So I have n heads and n tails. Okay, so nh and nt, they have to be arranged. Suppose n was 2, okay, n was 1, so two coin tosses, so 1 head and 1 tail had to be arranged. If n was 2, then total number of tosses would be 4, and 2 head and 2 tails would have to be arranged, so HH and TT. So this can be done in how many ways? 4 factorial divided by 2 factorial into 2 factorial. Since I have to arrange n heads and n tails and total out of 2n, so this can be done in 2n factorial by n factorial into n factorial. So this is the same thing as when you have to arrange n objects out of which m are same. So that will be n factorial by m factorial. So that's the same thing over here. So which is 2n factorial divided by n factorial square. Total number of outcomes will be what? Total number of outcomes will be for each coin toss you can have either head or tail. So 2 outcomes. When you toss it twice, that will be 2 into 2. That is 4 outcomes. If you toss it 2n times, you will get 2 raised to the power 2n outcomes or 4 raised to the power n. So the probability of getting n heads and n tails will be this number divided by this number. Okay, so 2n factorial by n factorial squared divided by 4 raised to the power n. So the probability that the number of heads is not equal to the number of tails is 1 minus this whole thing. So 1 minus 2n factorial by n factorial squared divided by 4 raised to the power n. So option D is the correct option. Now let us come to problem number 7. Let Px represent the probability mass function of a Poisson distribution. Poisson distribution. So this is a French word. It was the name of a French scientist. So in French you can pronounce it as Poisson. Americans may pronounce it as Poisson. We just called it poison because it's just so easy. People just don't understand Poisson or Poisson. We just called it poison distribution, so it works. I will just call it poison just for easiness of it. So let Px represents the probability mass function of a Poisson distribution. If its mean lambda equals to 3.725, then the value x at which Px is maximum is. Okay, so we know that the probability mass function of a discrete random variable x with parameter lambda is given by this. Then this is called as Poisson distribution. Okay, x is the number of occurrences. We have to note that x is discrete, so the occurrences can be 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6. It cannot be 1.5, it cannot be 2.9, it cannot be 3.1. Okay, since it's a discrete number. So now I have to compute x so that Px is maximum. The graph should look something like this. If you plot Poisson distribution, it might look something like this. So it maximizes at this one point here, x. So I have to compute this x. Okay. So what is given to us, that the mean lambda is given to us as 3.725. So for Poisson distribution, we know that the mean is equal to variance is equal to lambda, which is this parameter over here, lambda. So my probability distribution function is 3.725 raised to the power x into e raised to the power minus 3.725 divided by x factorial. Okay, so this is a very difficult function. If you want to take the derivative of it and then equate it to 0, you will not be able to solve it. It's very tough. Okay, so what I will do is I will just start putting in the values and that's it. It's easy and done. I don't need to find the value of this because this is a constant and it will be present in each of the probabilities. So it's common. We don't need to find its value. When I put x equals to 1, it will be 3.725 raised to the power 1. This is constant divided by 1 factorial. So approximately 3.72 into this number. For x equals to 2, this will be squared and divided by 2 factorial, which is 2. So I've done the calculation. It comes out to be 6.93. For x equals to 3, 3.725 cube divided by 3 factorial is 8.61. When you put x equals to 4, you will get 8.02. When you put x equals to 5, you will get 5.97, all multiplied with this number, e to the power minus 3.725. So as you can see, it starts increasing and then it goes on decreasing after x equal to 3. X equal to 3, I am seeing the maximum 8.61. It was increasing from 3.72 to 6.93 to 8.61 and then it starts decreasing to 8.02, 5.97. So my maximum is happening at x equals to 3. So x equals to 3 is the solution. That's it. Okay, so that's it. The 7 problems. See you all next time.